All right, today 6.5% of increase and decrease. And so a percent of change is the percent a quantity changes from the original amount. The original amount, the percent that it changes from the original. Now, this can be a percent increase, meaning that the new amount is higher than the previous amount, regardless of what you're tracking. Maybe you're tracking mice in your house. You went from 1 to 3. That's never good, right? That'd be a percent increase. Maybe you're talking about your bank account and you went from, I don't know, $145 in there down to $106. And so that would be a decrease. And so regardless of whether your percent change is an increase or decrease, it doesn't change how we find it. The way that we find a percent change is we do difference over original. Now, what does the word difference mean in math? Frank? Not division, you're thinking quotient. Addison? Subtraction. So what we're going to do is we're going to have two numbers. We're going to have an original number and we're going to have a new number, whether it's, an increase or decrease. We're going to subtract those two to find out what the difference is. That'll be our numerator. Our denominator is going to be the original number, which is always going to be the first one that they give you. Whatever that first number is the original amount. Well, now when I'm saying numerator and denominator, what does that tell you I'm referring to? Fractions. Okay. I don't want a fraction of change. I want a percent of change. What we're going to do is once we write our fraction of change, our difference over original, we're going to change that fraction into a decimal, and we're going to change that decimal into percent. Sound familiar? We spent 3 days doing that to start off this chapter, didn't we? Fraction, decimal, percent. So let me show you how we do this. Example A, 12 increases to 20. The first thing I'm going to do is to find out what that difference is. Now, you could probably do this in your head, but what you're not going to be able to do in your head is the division that we're going to have to do to go from fraction to percent. So if you don't have a calculator out on your desk, go ahead and get one out or borrow one so you can do the division with us. Ella, tell me what the difference is between 12 and 20. When it says 12 increased to 20, how much did it go up by? Thank you, Ella. Yeah, it went up by 8. That we could probably do in our head, right? Now I'm going to write it down for all those that are following along at home so they can see that we just subtracted. Now, I know that 12 is listed first. If you do 12 minus 20, you'll get -8, which it's still 8, it's -8. We don't want any negative answers today. So just make sure, regardless of what order they give the numbers to you in, do big minus small. So your answer always ends up positive. Or if you do 12 minus 20 and you get -8, just drop the negative. We're not doing negatives in this chapter. We've already done negatives. We'll come back to them, but we've already done them. They're not going to have negative percents in this chapter. So 20 minus 12 is 8. That is our difference number, and that goes on top of our fraction. The original amount is the first one that they gave us, which is 12. So my fraction of change is 8 over 12. My decimal of change is 8 divided by 12. 8, top number, top divided by bottom. 8 divided by 12, 0.6 repeating. In fact, your calculator is going to make that last digit a 7 because it rounds that last digit, but it's 0.666666, just goes on forever. And then my percent of change, I slide the decimal over 2 spots to the right. Normally I fill in with zeros. However, I have a repeating decimal here. So it's not a 0 I'm going to fill in. It's another 6 that I'm going to fill in and another 6. And that's now going to be 66. I'm just going to write it over here. 66.6 repeating percent. Or since Big Ideas does not let you write repeating decimals, 66. And do you remember what 0.6 repeating is as a fraction? 2/3. Yes, you guys remember 2/3. thirds. In fact, if you reduce 8/12, you'll get 2/3, and that's why it repeats. So 66 and 2/3. Don't forget to write your percent symbol. I noticed when I was looking at your work papers, some of you are not writing your percent signs. Realize that it's different when you like leave the dollar sign off of a number, but when you leave the percent sign off of a number, it completely changes your answer. 66 and 2/3 is a lot bigger than 66 and 2/3 percent because that means it's out of 100. All right, so let's recap. What did we do? We subtracted to find our difference amount. We put that 8 on top. We wrote the first number, the original, on bottom. We divided to turn it into a decimal, and we slid the decimal point over to write it as a percent. Sometimes our decimals are repeating. Sometimes they are. This one's not going to be repeating. 50 decreases to 25. It doesn't matter if it says increase or decrease, you still do the same thing. Subtract. If 50 decreases to 25, what does it change by, Parker? What's 50 minus 25? 25, okay. So 25 is going to go on top. We'll take it one step at a time, okay. 25 is our difference. Our original number, first one they give us, 50. That's our fraction of change. Percent over, or sorry, difference over original. In fact, I wrote that up here on the board. You might want to write difference over original on when you're doing your work paper tonight, just like kind of on the top, because you're going to use that over and over and over and over again. You just have to remember the difference means what? Answer to a subtraction. Yeah, so difference means subtract. Yeah. All right, so there's my fraction. Now I'm going to divide this and get a decimal. Caden, what do you get when you divide 25 divided by 50? 0.5. Slide the decimal over 2 spots. What's that going to be as a percent? 50%. Good job. So we're just going to say 50%. That's a bad looking 5. That's how you find percent of change. Subtract the two numbers. Put that on the number. Put that number as the numerator. Put the original number as the denominator. And then once you have your fraction, change that fraction to a decimal to a percent. Divide and then slide. The table shows the number of hours you spent online last weekend. What is the percent of change in your online time from Saturday to Sunday? Saturday, you spent 2 hours online, and then that's going to go to 4.5 hours on Sunday. So my question is, what did it change by? How many more hours did you spend online Sunday? 2.5. You get that just simply by subtracting. So when it says difference over original, the reason we find the difference is that tells us how much it went up or down by. So big minus small. Again, regardless of what order they give it to you, just do big minus small. 2.5 is the number of hours that we increased our screen time by on Sunday. That's our difference. That's going to go on top. What was our original number, Frank? 2. Yeah, it was just the one they gave us chronologically. The 2 came before the 4.5 because it was Saturday's number instead of Sunday. And we're going to turn that fraction into a decimal just by dividing. Hannah, what do you get for 2.5 divided by 2? Good. And what would 1.25 be as a percent? Good job. Slide it over. No extra digits that we have to add on this one. 125% is our answer. 125% increase. The bar graph shows a softball player's home run totals. This might be for a high school player's career. It's 4 years. It says, what is the percent change from 2012 to 2013? So that's going to be the last 2 years, their junior and senior year. 28 home runs. That's actually going to decrease to 20 home runs. I want to find the percent of change. So I'm going to start off by finding the difference. And again, you may not even need a calculator for this part. How many fewer home runs did they hit in 2013, Lucas? 8. So when I do, and if you don't want to write 28 minus 20 down on your work paper because you already know the answer to that, fine. You don't have to write that. What you do need to write though is that top number, which is 8, over the bottom number. What was the original number of home runs in 2012? 28. So on your work paper, you at least need to write out what that fraction is going to be, even if you don't want to write the different, you know, if you can do the subtraction in your head, that's fine. Now that we have the fraction, 8 fewer home runs, so 8 was the difference, 28 is the original. We're going to divide 8 divided by 28. And that's not going to give us a very nice decimal. Now, what I'm going to do is I'm going to have you write 4 decimal places down. Okay, because we're going to round to 3. So I need the 4th one. So I'm going to write 0.2857. So don't count the 0 as one of those decimal places because it comes before. 4 decimal places. Here's why we need 4. Right out of the gate, we're going to move the decimal over 2 spots to go from decimal to percent. So now we already have only have 2 decimal places. If my decimal does not stop, so it doesn't terminate, I want you to write 1 decimal place after the decimal. So why do I have 2? Because I need to peek at this number to see what's going to happen to the 5. Does the 7 bump the 5 up to a 6? It does. So when I write this, 28.6%. Again, I need 4 decimal places, 2 that I'm going to move over immediately, and then 1 that's going to help me decide what happens to that 3rd one. The 5 had to bump up to a 6 in this case. We call this rounding to the nearest 1/10 of a percent. 1/10 of a percent means the nearest 10th, which is 1 decimal place, after you've already made it a percent. So her home run total decreased by 28.6%. Questions on that? Subtract, divide, and slide. Okay, maybe round. You could add that. Sometimes you have to round. Actually, usually all the time you would have to round, but sometimes it means it bumps up. Sometimes we're going to look at some cases where it doesn't bump up when we round it and it doesn't bump up. That's what do they say? 5 or more raise the score. 4 or less, let it rest. Okay, yeah, that still comes into play. All right, I want you to try these next 3 on your own. If you're watching this video at home, you can pause right here. Actually, I'll probably pause the video. Go ahead and try these 3 on your own using difference over original, and we'll go over
You step on my shoe?
on purpose. Yes.
Dude, they're new.
Okay, so you've had some time to work on this. Let's look at example A. It went from 10 inches to 25 inches, whatever this is. So we're going to start off by finding the difference. Andrea, what is the difference between 10 and 25? 15. Yeah, so that's a change of 15. 15 is going to be the top number of our fraction. I guess I can put that up here. The bottom number of our fraction is going to be the original, which in this case is just the first number, which is the 10. So we have 15 over 10. That's our fraction. We're going to change that into a decimal. Andrea, what is 15 divided by 10? 1.5. And what's 1.5 as a percent? 150%. Good job. So it's 150%. Would this be an increase or decrease? Increase, yeah, 10 to 25 would be an increase, yeah. What about 57 to 65? Is that an increase or decrease? Increase again. It doesn't really change how we find it. It doesn't change anything about how we find it. So example B, we're going to subtract the bigger number minus the small number. That's just so we don't get a negative answer, even though the negative answer would just be the opposite of the positive answer we're going to get. And that's a difference of 8. We put 8 over the first number, the original number, which is 57, not 65. I noticed that being a big issue in last period. If they were getting it wrong, it's because they were putting the wrong number on bottom. Put the original number on bottom, original first. Then we're going to divide that. Subtract, divide, and slide. So we've done the subtraction. Now we're going to do the dividing. I'm going to write 4 decimal places down. 1, 4, 0, 3. There's my 4 decimal places. Now I slide. Move the decimal over twice. The reason I wrote the 3 down is because even though I only want 1 decimal place after the decimal, I still need to see if the 3 is going to bump the 0 up. It's not going to bump the 0 up. So I just write this as 14. And if you wrote 14%, that's fine. I would write this as 14.0. And that's because it tells the mathematicians out there, usually when you write an answer like this, that means it's not exactly 14%, it was rounded. Because if it was exactly 14%, I would have put 14%. This just tells you that it was rounded, it's not exact. So 14 or 14.0%. And then the last one, $115 to $10. Is this a percent increase or decrease? This will be a decrease. Yeah. Again, it doesn't change how we solve for it. Subtract, divide, and slide. If you go from $115 to $10, you made a big purchase. I'm assuming this is how much you have in your piggy bank, right? How much was the purchase for? No, probably. $105. Yeah, you spent, your bank account went down $105. So we put the difference on top. Remember, it's difference over original. Difference over original. So difference goes on top. The original amount was the 115. That's going to go on bottom. And then we turn that fraction into a decimal. Subtract, divide, and slide. 105 divided by 115 is 0. We're going to write 4 of them down again. 9, 1, 3, 0. Slide. Move the decimal over twice. Does the 0 bump the 3 up? It doesn't. So this is just going to be 91.3. You spent 91.3% of your savings on whatever that was. Got a lot of homework problems in here. Wow. We'll look at some. Actually, our next one's a homework problem. This is number 26 on tonight's homework. We are going to write them in our notes. And then when you get to your work papers, you're just going to have to copy it onto your work paper. We're still writing it on our work paper, but let's go ahead and copy this one down in the notes. So I guess you'll just have to refer back to the notes when you're doing the 6.5 homework. Number 26 says, suppose the length and width of the sandbox are doubled. Find the percent change of the perimeter for part A. For part B, find the percent change of the area. We'll start with part A. Part A is the perimeter. So I'm going to put a P here for perimeter. And I'm going to write 2 words up here because we need 2 numbers. One of them is going to be the original number. One of them is going to be the new number. We'll start with original. Aiden, can you tell me how to find the perimeter of a rectangle? Okay. So Aiden, when you add 10 and 6 with another 10 and another 6, what's that going to give you for the perimeter? 22. Are you sure? Wait, 22? I think we forgot 1 10 in there. 32. Yeah. So the perimeter is going to be 32. 6 plus 10 plus 6 plus 10. We need an original number and we need a new number. If it's doubled, is that going to be an increase or decrease? Increase. Okay. So if it's doubled, our new dimensions are now going to be 12 and 20 for our length and our width. So what would the new perimeter be? 12 plus 20 plus 12 plus 20. Hayden? Not 52. Addison?
72.
Not 72. Lucas? 64. Yeah, the new one's going to be 64. 20 and 20 makes 40. 12 and 12 makes 24. And 40 and 24, 64. Okay. Now I'm able to find my percent change. What's the difference? What's the difference between 64 and 32? It's just 32, isn't it? Yeah. So difference over original. The original perimeter of the sandbox was 32. What's 32 divided by 32? 1. And what's 1 as a percent? Be careful here. To slide, it's 100%. Yeah, so it's actually 100%. So if something doubles, it's 100% bigger. If I had $5 in my bank account and I doubled it, not only do I have that $5, but I have another $5. So I've got 100% more of what I have. So if something doubles, it doesn't get 200% bigger, it's 100% bigger. Okay, part B. Now we're going to use find the area. Lainey, can you tell me how to find the area of a rectangle? That's right, length times width. So our original length, Lainey, would be 6 times 10. What's 6 times 10? 60. Our original area is 60. Remember, we're going to double that. So the new area would be 20 times 12. What's that, Natalie? 240. Okay. I only need 2 numbers, right? Just like we need up here. I only needed 2 numbers to find my percent change. I needed the original number and I needed the new number. Now I have them both. So if you go from 60 to 240, what's that a difference of? Addison? 180. Yeah, our sandbox area got 180. We got 180 more square feet. What was the original area of the sandbox? That's the new one. 60 was the original, right? So 60. So I'm going to divide. So I've subtracted. I'm going to divide 180 divided by 60. That's just 3. 60, 120, 180, right? That's just 3. And then 3 as a percent, slide it over twice, is going to be 300%. So if something quadruples in size, here's why it quadrupled. Look at the sandbox. If I double the width and I double the length, sorry, I just added 3 more sandboxes in there, didn't I? That's why it's a 300% increase. Because if you double the length and you double the width, it's like adding 3 more sandboxes to what you already have. So 300% change. Okay, that's one homework problem done. Now, the second part of the lesson, and it's really not even a full part because it's very similar to what we just did, we're going to talk about percent error. Percent error is the percent that an estimated quantity, again, differs from the original amount. So instead of me just giving you 2 numbers and saying 5 is now 22, I'm going to say, I thought there were 16 jelly beans in that jar, and it turns out there was only 10. Or I don't know. I could probably count to 16. I thought there was 516 jelly bars in that jar, jelly beans in that jar, and it turns out there was actually 604. Like that would be a percent error. Like I have my guesstimated answer, and then I have the actual answer. So if you look at the percent error, the only change that we see here, instead of difference over original, it says difference over actual. There's not going to be an original number. There's going to be a guess, a wrong answer, and there's going to be a correct actual answer. So let's look at this first one. You estimate the length of your classroom is 16 feet. The actual length is 21. Find the percent error. Well, how much was I off by? 5. So again, difference means subtract. If I guessed 16, it was actually 21. That means I was off by 5. So I'm still subtracting. But I do not necessarily put the first number on bottom like I did for all the other ones. I'm not putting the original number. I'm putting the actual. What is the actual length of the classroom? 21. So look for that word actual. It may not be the first number. It may be the second number. Just got to read. 21 is the actual length. Now I'm going to divide. 5 divided by 21 is 0. Use 4 decimal places. 2380. and then slide it to the right. And that's going to be 23.8%. The zero is obviously not going to do anything with that 8. So percent error is very similar to finding percent change. That's why they put them in the same lesson. Yes. What would your percent error be? So what would your percent error be? That's right, 0%. There was no error, right? Yeah. Your guess was exactly what it was. There was no difference. So your difference would be 0, that's 0%. Yep. All right, we can at least do part A of number 19. This is number 19 from tonight's homework. And then we'll actually look at a few more homework problems tomorrow. Tomorrow, we're just doing a review worksheet over the same material. So we'll do these homework problems, and then you guys can get started either finishing. Hopefully you're really close. If you could do all the homework problems tonight, except the ones that we're obviously going to do together, then you'll finish as soon as we're done, 10 minutes in class tomorrow, and then have the rest of the time on your worksheet. Number 19 says you estimate 200 people will attend the school concert. The actual attendance was 240. So you take the difference. How much are we off by? 40. If you don't want to write 240 minus 200 down, you don't have to. But what you do need to write down is that difference is 40 over what was the actual attendance? 240. And I'm going to convert that. It says round to the nearest 1/10 of a percent. That's exactly what we've been doing. It means one decimal place after you already changed it to percent. So 40 divided by 240. 0.1, and then which number repeats? Just the 6. Okay, so I'm going to slide the decimal over twice, 1, 2, but there's another 6 there. In fact, there's another 6 there. There's an infinite number of 6s. So that's going to be 16 point. Does this 6 bump the other 6 to a 7? It does. So we'll say 16.7%, and we will finish part B of this problem tomorrow. Have a great day. Please make sure you're getting missing assignments turned in if you had any from last week.
I don't know who you're